Hello students. Today we are going to start with the chapter straight lines. In the first part we are going to discuss slope of a line and the related formula and examples based on that. In the next part we will discuss the different equation of straight lines. We are going to solve different type of examples, so watch the video till the end. First we are going to see different formulae which we have already studied. The first formula is the distance formula. Distance between the points P, which has coordinates x1, y1 and q, x2, y2 is given by PQ is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. For example, if you want to find the distance between the points 6, minus 4 and 3, 0, the distance would be 5 units. The second formula is for dividing the line segment joining two points. The coordinates of a point dividing the line segment joining the points x1, y1 and x2, y2 internally in the ratio m:n are mx2 plus nx1 upon m plus n, my2 plus ny1 upon m plus n. For example, the coordinates of the point which divide the line segment joining a 1 minus 3 and b minus 1 11 internally in the ratio 1:3 are given by here m is 2 and m is 1, n is 3 and the points x1 1, y1 minus 3, x2 minus 1, y2 11. So putting the values in the above formula, we get the coordinates as 0 and 2. That means the point 0, 2 divides the line segment AB in the ratio 1:3. In this case, suppose if m is equal to n, then the coordinates of the midpoint are obtained. So coordinates of the midpoint are given by x is equal to x1 plus x2 by 2 and y is equal to y1 plus y2 by 2. The third formula is for finding the area of a triangle when the coordinates of the three vertices are given. Area of the triangle whose vertices are x1, y1, x2, y2 and x3, y3 is given by A is equal to half of mod of x1 into y2 minus y3 plus x2 into y3 minus y1 plus x3 into y1 minus y2. For example, the area of a triangle whose vertices are 4, 4, 3 minus 2 and minus 3, 16 is mod of minus 54 upon 2, which is minus 27. Mod of minus 27. Mod means only positive value. Obviously, area is always positive. It is in square units. So, the area is 27 square units. If the area of a triangle is 0, then the points are collinear. You know that collinear points means the points lie in one straight line. So if the area is 0, that means the points are lying in a straight line or they are collinear. For points P, x1, y1 and Q, x2, y2, if PQ is parallel to y-axis, then x1 will be equal to x2. Because a line which is parallel to y-axis will have all the x values same. So the distance would be PQ is equal to y2 minus mod of y2 minus y1. And suppose if PQ is parallel to x-axis, then y1 is equal to y2. So the distance PQ is mod of x2 minus x1. Now we will understand the concept of slope of a line. It is an important concept. The angle, say theta, made by the line L with the positive direction of x-axis and measured anti-clockwise is called the inclination of the line. And here the angle theta lies between 0 and 180 degree. That means in the diagram you can see, suppose a line L is making an angle theta with the positive x-axis and you are going in the anti-clockwise direction. Then the angle of inclination is theta over here. Now it is clear that lines parallel to x-axis or coinciding with the x-axis will have inclination 0 degree, and the inclination of a vertical line means parallel or coinciding with the y-axis is 90 degree. Now if theta is the inclination of a line L, then tan theta is called the slope or the gradient of the line L, and it is denoted by small m. That means m is equal to tan theta, and theta is not equal to 90 degree because you know tan 90 degree is not defined because it is 1 upon 0 which is not defined. The slope of a line whose inclination is 90 degree is not defined, and the slope of x-axis is 0 and the slope of y-axis is not defined. Now let us understand the concept. For example, to find the slope of a line which makes an angle of 30 degree with the positive direction of the y-axis measured anti-clockwise, you want to find the slope. Now suppose if a line makes an angle of 30 degree with the positive direction of the y-axis, remember here it is y-axis which is measured anti-clockwise, and the angle made by the line with the positive direction of the x-axis measured anti-clockwise will be 90 degree plus 30 degree or 120 degree. From the diagram it is clear that if theta angle is made with the y-axis, then if the formula which you have tan theta, it is based on the positive direction of the x-axis. So you convert it in this form. So if it is making angle theta with the y-axis, then the angle in this case made with the x-axis will be 90 degree plus 30 degree or 120 degree. So the slope of the line will be tan 120 degree. Tan 120 degree means you can write it as tan of 180 degree minus 60 degree. And you know tan of pi minus theta is minus tan theta. Why? Because in the second quadrant ASTC only sign is positive, tan is negative. So the answer is minus root 3. Now, how to find the slope of a line when the coordinates of any 2 points are given? The formula is m is equal to difference of y coordinate upon difference of x coordinate. Means slope m is equal to y2 minus y1 upon x2 minus x1. Remember, even if the angle is obtuse, that means for acute angle and obtuse angle, for both of them the given formula works. Remember, two non-vertical lines L1 and L2 are parallel if and only if their slopes are equal. That means two lines are parallel if and only if the slopes are equal. If the slopes are equal, the line will be parallel, and if the lines are parallel, slopes will be equal. Two non-vertical lines are perpendicular to each other if and only if their slopes are negative reciprocals of each other. Means m1 is equal to minus 1 upon m2, or m1 into m2 is minus 1. The acute angle, say theta, between lines L1 and L2 with slopes m1 and m2 respectively is given by tan theta is equal to mod of m2 minus m1 upon 1 plus m1 into m2, where 1 plus m1 into m2 is not equal to 0. If the angle is obtuse, say phi, then it can be just found by using phi is equal to 180 degree minus theta. 3 points ABC are collinear if and only if slope of AB is equal to slope of BC. We will see examples based on this. We start with the first example. Find a point on the x-axis which is equidistant from points 7, 6 and 3, 4. Now since our point is on x-axis, its form will be of the type A0. On x-axis, y coordinate is 0. So let A0 be the point on the x-axis that is equidistant from the point 7, 6 and 3, 4. It is equidistance means the distance between 7, 6 and A0 and the distance between 3, 4 and A0 both will be same. By using the distance formula, root of x2 minus x1 whole square plus y2 minus y1 whole square, we get the following equation. From solving the equation, we get 8a is equal to 60 or a is equal to 15 by 2. So our required point is 15 by 2, which is equidistant from 7, 6 and 3, 4 and which is lying on the x-axis. Second example. Find the value of x for which the points x minus 1, 2, 1 and 4, 5 are collinear. We have just now seen that if 3 points are collinear, then the slope of AB will be same as slope of BC. So suppose we are having these 3 points, we will use the formula for the slope. M is equal to y2 minus y1 upon x2 minus x1. The slope of the first 2 points, it will be 1 minus minus 1 upon 2 minus x, and for the second and the third point it will be 5 minus 1 upon 4 minus 2. So solving this, we get the value of x as 1. Example 3. Find the angle between the x-axis and the line joining the points 3 minus 1 and 4 minus 2. Now first of all, the formula of slope is y2 minus y1 upon x2 minus x1. So in this case, what will be the slope of the line which we are having? just use the formula, you will be getting the slope as -1. Slope is tan theta. So we have got tan theta equal to -1. So what will be, when will the value of tan theta be -1? When theta is 135 degree. Correct? Why? Because you know that in the second quadrant tan is negative. Therefore, the angle between the x-axis and the line joining the points 3 -1 and 4 -2 is 135 degree. Another type of example. The slope of a line is double the slope of another line. If the tangent of the angle between them is 1/3, find the slopes of the lines. It is given that two lines are there and the slope of the other line is double the first one. So suppose if the slope of one of the line is m, then the slope of the other line will be 2m. The tangent of the angle between them is tan theta is given to us. So if theta is the angle between them, then tan theta is equal to 1/3 is given to us. Using the formula tan theta is equal to m2 minus m1 upon 1 plus m1 n2 mod of that, we get two cases over here. Remember, in this case m2 is 2m and m1 is m. So now in the first case, since it is mod, so in the first case we are having 1/3 is equal to m in m upon 1 plus 2m square. Why m? 2m minus m, that is m, upon in the denominator 1 plus 2m into m, which is 2m square. So now this is a quadratic equation, and when you solve this quadratic equation, you will be getting the roots as 1 or half. The second case possible is, since it is mod, it can also be negative. So you can also have 1/3 is equal to minus m upon 1 plus 2m square. So now if you solve this equation, you get m as -1 or minus half. So the possible, one of the line has slope m, another one has double. So the possible values of the slopes of the line are -1, means if m is -1, 2m is -2. So -1 and -2, minus half and -1, 1 and 2, or half and 1. Now example 5. A ray of light passing through the point 1, 2 reflects on the x-axis at point A, and the reflected ray passes through the point 5, 3. Find the coordinates of A. Now you know that in reflection, angle of incidence and angle of reflection are the same. So suppose the ray is reflected at the point A on the x-axis, and let the coordinates of point A be A0. Then in this case you have BA as the incident ray and AC as the reflected ray. And angle of reflection and incidence will be same, means angle BAL will be same as angle CAL. Now AC makes an inclination of theta with the x-axis. So tan theta by the formula will be y2 minus y1 upon x2 minus x1. So now the tan theta value will be 3 minus 0 upon 5 minus a. Similarly, if I want to find the slope of line AB, the slope of line AB will be the angle of inclination BAX. Now the angle BAX can be also written as 180 degree minus angle theta. You can see that from the diagram. So now we can write slope of AB as tan of 180 degree minus theta. So which is nothing but minus tan theta. So minus tan theta is equal to, now here the difference of y coordinate is 2 minus 0 and x coordinate is 1 minus a. So from equation 1 and 2, when you solve equation 1 and 2, both are equal, equate them, you will be getting the value of a as 13/5. So the coordinates of a are 13/5, 0. Some assignment examples from the first part of the chapter, which is slope of the line. First one, draw a quadrilateral in the Cartesian plane whose vertices are -4, 5, 0, 7, 5, -5 and -4, -2. Also find its area. Now you have studied the formula to find the area of a triangle when 3 points are given. So just divide this quadrilateral into 2 triangles and add their areas. The answer is, area of the quadrilateral is 60.5 square units. Second one, without using the distance formula, show that the points -2, -1, 4, 0, 3, 3 and -3, 2 are the vertices of a parallelogram. Now here if you can show that slope of AB is same as slope of CD and same way slope of BC is same as slope of AD, then what we have from a result, if pair of opposite sides are parallel, then it will be a parallelogram. So here since slopes are equal, we have seen a result before, the lines will be parallel, hence it is a parallelogram. If the lines, third one, if the lines 2x plus y minus 3 equal to 0 and 5x plus ky minus 3 equal to 0 and 3x minus y minus 2 equal to 0 are concurrent, find the value of k. Concurrent means they pass through a common point, and the point of intersection, when all the three lines pass through a common point, we know that the point of intersection of any two lines will be lying on the third line. So in this case, first find the point of intersection of two lines and then put in the third one. So you will be getting the answer of k as minus 2. We have covered the first part in which we saw the slope of a straight line. Please subscribe to the channel for the next video which will cover the different equations of a straight line. Please like and share the video and subscribe to Math Practice.